The next polymer to be studied in detail is rubber. See, rubber we know is a natural polymer. It is obtained in the form of a latex from the rubber tree bark. Now, it is actually is a linear polymer of the monomer called isoprene. Isoprene chemically is 2-methyl-but-1,3-diene, buta-1,3-diene. Now, when this molecule isoprene undergoes polymerization, it leads to the formation of this type of polymeric chain, which is having a methyl as a side branch. Now, and the double bonds these two double bonds shift to the central position. Now, this natural rubber exists in the nature in its cis form, like CH3, CH2 double bond, CH2 is here. So this methyl and this CH2 are with respect to each other are opposite. So like this one, they are on the same side, so it's called cis. And then CH2, CH2, CH, CH3, CH3. So then again these are on the same side. So what we find is it's a cis form. So natural rubber exists in cis form. And that is why it cannot be packed very close to each other. That is why it is very soft in nature. Though it has a lot of coiled structures, that is a lot of coiled polymeric chains. As a result, it can be stretched to full length and shows the property of elasticity. But what we find is this natural polymer is having weak van der Waals forces, and that is why it is susceptible to what it is easily breakable, it breaks easily, it absorbs a lot of water and is not very strong polymer. Now, that is why what we do is, in order to make it strong, we do its vulcanization. Now, what is vulcanization is? Vulcanization is heating natural rubber with sulfur. This is vulcanization. Now, what is vulcanization is? Heating natural rubber with sulfur at about 373 to 415 Kelvin. So, when natural rubber is heated with sulfur from 373 Kelvin to 415 Kelvin, vulcanized rubber is formed. Now, this rubber is much harder and stronger. The reason being, this polymeric chain, which was having earlier the bonds like this was the chain. Now, what happens is, I can show you it like this. See, this is the concept we have. Now, these are the two chains. Now, when they are allowed to undergo vulcanization, these double bonds disappear and they both joins each other through the sulfide linkages like this. So, the sulfur is used in making cross linkages, which makes it very hard and strong and tough. And that is why this vulcanized rubber can be used in making tires and other type of things. So, this is what is called vulcanization of rubber. Now, let us move to the synthetic rubber. See, we know that natural rubber is not very good in the properties. The reason being, it's very soft, it absorbs a lot of moisture, it is not very tough, and that is why we do vulcanization. But natural rubber is not able to actually fulfill all the requirements of the rubber which we have in our day-to-day life. So, we have developed number of artificial rubbers. The first in the list is your neoprene. See, synthetic rubbers can be a homopolymer or can be a copolymer. The homopolymers will be the products of the 1,3-butadiene or its derivatives, and copolymers can be buna-N or buna, as we will be taking out later on. Now, but first, let us see the neoprene, which is actually a type of a homopolymer. Neoprene is very similar to a natural rubber, but the only difference is that in place of this methyl, we are having a chlorine here. So, the monomer is called chloroprene. So, you can clearly make out that chloroprene resembles isoprene, which is the monomer of the natural rubber. The only difference is that it is having a chlorine and the isoprene of the natural rubber was having a methyl here. So, this is a 2-chloro-buta-1,3-diene. This when it's actually subjected to polymerization, leads to the formation of this type of a polymer, where like this one. So, this is called your neoprene. Now, this neoprene is resistant to vegetable and other oils, and that is why it is used in making conveyor belts, gaskets and your hose pipes. So, that is why it has a lot of application in that sense. So, it is a very important one of the synthetic rubbers we have developed. The second type of, remember it's a homopolymer because it's made up of only one type of molecular species. Monomer is made up of only one type of molecule. Then let's move to the two important copolymer synthetic rubbers we have. This first one is your Buna N. Buna N, as the name indicates, it's a polymer between butadiene and acrylonitrile in presence of sodium. So, bu means butadiene, N means acrylonitrile, and is sodium. So, when this butadiene is combined with acrylonitrile, this is acrylonitrile, this is butadiene, what happens is we get a rubber like this. And this is what is called your Buna N. Now, this Buna N is very resistant to organic solvents, to petrol and other type of hydrocarbons, and that is why it is used in making tank linings and in making the oil gaskets and oil seals, etc. So, it is again is a very important synthetic rubber which we have developed, which has a lot of applications in the petroleum industry. Then we have another very similar type of synthetic rubber which is called Buna S. S means styrene here. It's a copolymer between butadiene and styrene, which is having a benzene ring in place attached to the vinyl group. So, this is called your styrene molecule. This is butadiene. Now, when these two combine, the monomer polymer formed is this. So, this is called Buna S. Buna S is a very good substitute of the natural rubber, and that is why it is very widely used in making automobile tires. It is used in making what that's the most important another use, floor tiles, which makes it what non-skidding floor tiles, and it is also very much used nowadays in making footwears. So, it's a very good substitute of your natural rubber, which is Buna S.